Hi guys, this is a quick video on how to make a Raspberry Pi Zero Bitcoin tracker and some of the things that you're going to need. First, you're going to need a Raspberry Pi Zero Wi-Fi. So look for model numbers like Raspberry Pi Zero W and make sure that it's got this 40-pin SPI header pre-attached to it. Mine came without it, so I soldered it on after, but if you haven't got the soldering equipment, then just make sure that this is pre-installed. Next thing you're going to need is a 2.13 inch e-ink screen. This came from waveshare.com. I'll put a link in the description. And it costs around $20. And then you're going to need a micro SD card reader and also a micro SD card. The operating system that we're going to be installing is Raspberry Pi OS, and I think the minimum requirement for it SD card wise is 8 gig. So I've just got a 16 gig one because it's fairly cheap still, and it just saves me having any space issues. And then optional is a case. So this case is from the Pi Hut in the UK. It's around £6. And it's just made out of Perspex. It's pretty simple to put together and it just keeps all of this kind of equipment safe. But there are other cases out there, but you'll just have to make sure that if you do buy one that it's compatible with the Waveshare screen, as when this is attached it'll make things a little bit thicker. So in terms of the hardware installation, getting the screen onto the Raspberry Pi is pretty simple, but I found that there's a better way to do it, because I found that if I push the screen on this way, I feel like I'm going to crack the glass and the LCD here. So best way to do things I found was put the screen flat on your desk, take your Raspberry Pi with the pin connector downwards, and then just line it up with those holes there. So it's like this. You can give it a little push, but you don't have to push it all the way in yet. And then flip it round and put your thumb on the back of the SPI connector and just give it a press. And it will stop you feeling like you're going to crack the LCD by kind of crushing it with your fingers like this. And then once that's pressed in, it should just stop. It'll be fairly positive. You might find when the screen's new that it'll be quite hard to get it into that connector, but as long as you've got it lined up and you give it a push, you won't have any problems. When it's in, the connector on the back of the screen will ride against one of the USB ports, and on the SPI side there'll be a gap, so that's normal. It'll be around 2 to 3 millimeters, and then once you've done that, you're pretty much done with the screen installation. So, very first thing that we need to do is image our micro SD. So get that plugged into your reader and plug that into your machine now. I'm going to be using Mac OS for this, so I'm going to download the Mac OS Raspberry Pi imager. If you're on Windows, just download the installer and go through the install process. Mac OS anyway, just open the DMG, drag over the imager to the applications folder and you're done, and then you can start the imaging software. Once that's started up, we just need to choose a few options here. So choose the operating system and choose Raspberry Pi OS 32-bit. Choose the correct storage and make sure it's the micro SD and not a different USB stick. And then on Mac OS, hold Command-Shift-X and click yes to the prompt and enter your login details here. And we just need to select some options here so that we can enable SSH and we can enable wireless. So tick set hostname, leave it as Raspberry Pi.local. Tick enable SSH and give it a password that you know that's secure. Configure your Wi-Fi network. So in terms of the SSID, that's going to be your Wi-Fi network name, and then add the password for that Wi-Fi network as well, and also choose the Wi-Fi country. And then everything else you can leave as default. Just click save here and then click write. It will give you one last warning to say it's going to delete everything on the micro SD. So click yes to that, and then put in your login details again. For Windows, I'm not sure if you'll need to put those login details in, and then the write process will start. So this is going to take about 10 minutes, so I'm just going to fast forward the video here, but what you're going to see is it writing and then it verifying, and then it will give you a notification to say whether it's been successful or not. And then once we've done all of that, you can take the micro SD out of your machine and plug that straight into your Raspberry Pi. So we're just coming towards the end of the imaging process, and the Pi imager will automatically unmount the micro SD, and this is a message that you'll get if everything's been successful. So once that pops up, just click continue, close the Raspberry Pi imager, and then you can pull the micro SD and plug that into your Raspberry Pi. So you've finished imaging your micro SD and you're ready to power on the Raspberry Pi. You just need to plug that micro SD into the micro SD slot on the left hand side. Don't worry if it doesn't go all the way in, that's normal, it sits a little bit proud. And then to power on the Raspberry Pi, we're going to need a micro USB cable, I think it is, and it goes into this slot here. There's one thing to note here. Once you power this on, don't unplug this cable until we've finished entering all the commands we need to set up the Bitcoin tracker. There's a bit of a thing where if you unplug this before connecting to it, you won't be able to connect to it via SSH again, and you'll need to re-image the micro SD. So once you plug this cable in, just leave it plugged in and allow it to start up now. If everything's going okay, you'll see a small status light under here which will show the Raspberry Pi booting up, and this is going to take about 90 seconds to 2 minutes, maybe even a little bit longer, to connect to your network. So give it 2-3 minutes and then we'll start entering some commands and make sure that this is connected. So you've powered your Raspberry Pi on, you've left it for a couple of minutes, and now we need to see if that Raspberry Pi is connected to your network. On Windows at this point you need to open a command terminal. On Mac OS you need to open terminal. So go to Applications, Utilities, and then open terminal. From there it'll give you this black box. The first command that you need to paste in is ping raspberrypi.local. Copy and paste on a Mac is Command C to copy and Command V to paste, and I think on Windows is Control C and Control V. So copy the first command, and all of this is going to be in the description, and paste it into your terminal. If your Raspberry Pi is successfully connected to your Wi-Fi network, this is the kind of response that you're going to get in the terminal, and you can just press Control C to cancel it. And then if you type in clear, that'll just clear your terminal window, so you can enter some new commands. On Windows it's pretty much the same, but just with Control C and Control V, and the response from your Raspberry Pi will look fairly similar. If it's not connected, you might get something like no route to host, or host not found, or something like that. So you might need to go through the imaging process again and double check that your Wi-Fi settings were correctly inputted into that advanced menu. So once you've done that, this command is for Mac only, and I'm going to go through Mac first and then the Windows side of things after. So we need to enter this SSH keygen -r raspberry pi.local. So copy that and paste it into a terminal. It will give you a small output. Don't worry about what it says. And then this is the command SSH pi at raspberry pi.local. This is a command that actually allows you to log in. So paste that into the terminal, and you're going to get this yes/no question. Just answer yes to that, and it's going to ask you for a password. Now, when we were imaging the micro SD, we had to enter a password, not the Wi-Fi one, the other one. That's the password that you're going to be entering here. So I'm just going to enter that now, and it's going to complete the login process to my Raspberry Pi. So now we're actually connected via SSH over Wi-Fi to the Raspberry Pi, and we can start entering some of our commands. So one of the first things that we need to do is expand the file system on the micro SD. So if we copy this sudo raspberry pi config command and paste it into the terminal, we're going to get a small window. The controls here are actually using the arrow key, so up and down will go through the menu, and left and right will allow you to select the menu options at the bottom. So if you go down to advanced options and then to expand file system, what this is going to do is just allow us to use the entirety of the micro SD, and when it's finished, this is the message that you're going to get. So you can just click OK to that, and then if you press the right arrow and go to finish, that will now ask you to reboot. So if you press yes to this, the reboot again will take around 2 to 3 minutes. Your terminal window will be still left on this Pi Raspberry Pi prompt. If you press enter here, you'll see nothing happens. So just give it a couple of minutes and let it boot back up. Okay, so it looks like my Pi's booted back up, and in my terminal window, if I press enter, it will just come back to my standard command prompt. So what we need to do is log back into the Raspberry Pi. So if you copy the SSH Pi at Raspberry Pi.local command again, paste that in, it'll ask you for the password this time. You won't get that prompt that says you've got to type yes, it will just straight ask you for the password. Press enter, and then it's going to take us back to the prompt where we're logged into the Raspberry Pi. We've done the expanding of the file system, that's a one-time thing. So the next thing that we need to do is update the software before we start doing anything else. So if you copy this sudo apt-get command and paste that in, and this is the sudo apt-get update command, and press enter. This is going to take a while, it's a little bit dependent upon your Wi-Fi network speed. So just let that complete, and I'll fast forward the video for this part. And once that's finished, it'll just bring you back to the prompt. And the next thing that we can do is the sudo apt-get upgrade. So if we just copy that and paste that in too. So those two commands are finished, and now we're going to move on to enabling the SPI connector and installing the rest of the software for the Bitcoin tracker. So this section's just for the benefit of Windows users. I don't think you'll be able to use command to log into your Raspberry Pi and enter all the commands you need to set it up. So you're going to need another program, and I think it's called PUTTY, and you can download it from putty.org, and it kind of looks like this. And what you'll have to do is enter Raspberry Pi.local into the host name box, and then select SSH and open. And what that will do, I think the first time it will pop up a security warning, so just click yes to that, and then it will give you a terminal-like window that says login as. So you'll have to log in as Pi, and then if you press enter, ask you for your password. Once you've entered your password, you can carry on with the rest of the commands by expanding the file system and updating your Raspberry Pi. So we've done the initial setup, and now we need to do the bulk of the work to get the software running. So for that, you need to head to github.com/Dr Mod and its Zero BTC screen. I'll put this link in the description. And here you need to click on code, and it'll take you to this page. If you scroll past the pictures at the top, you'll see the installation section, and we're going to generally just follow every command here and punch them into terminal or PUTTY. Before that though, give this guy some love. He's spent a lot of time developing this software. I'm a software developer myself, and to just give this out for free is pretty cool, so just give him some thanks. So the very first thing that we need to do is run this command here. So if we copy that and paste it into the terminal, this is going to bring up our configuration screen again. And if we go down to the interface options and then the SPI option, we can press a left arrow and enable the SPI interface. So that's the 40-pin connector, and we're just enabling that hardware interface. When it's enabled, you'll get a message, so then you can just press OK and then press the right arrow key and finish. The next thing we need to do is install some dependencies. So Dr Mod software runs on Python by the looks of it, so we can ignore the first command, which is the apt update, because we've already done that. So we need to grab this software here. So if we copy this second command, which is sudo apt-get and install Python 3 and pip and pill and stuff like that, and paste that into the terminal and run that. This might just take a while. It's got to download and install a bunch of dependencies. So I'll fast forward the video here. Now we need to copy the next command, which is the pip3 install. So we'll just paste that in to the terminal and run that too. I think this is probably some sort of SPI connector software. This looks like it will probably take a while, so I'll fast forward this to the next section where we're installing the actual drivers for the display. So with the pip3 install, you might notice that it will just hang on a blank terminal for a while. Just give it around a minute or two and it should get through that and install the correct software. So now we need to install the wave share display. So the first one is we're going to clone this repository. So if we copy that, git clone GitHub wave share ePaper repository and press enter, it will just copy that information from GitHub and place it onto your Raspberry Pi's microSD. This looks like it'll take a while too, so I'll fast forward this also. And then once that's finished, there's quite a few files there, so that might take a while. We're going to use pip3 to install that ePaper wave share driver. So if we copy the pip3 install command, paste that into the terminal and run that too. Okay, so the Waveshare driver has been fully installed, and we're going to install another dependency called Inky. So if we just copy the pip3 install Inky command and paste that into the terminal, once again just press enter and allow that to complete. I'll fast forward the video to the next part where we're actually installing the BTC screen. Okay, so Inky is finally installed, and now we're going to download the BTC screen software and install that. So again, copy this command here, paste that into the terminal, and it will pull down that repository and install that. So you're actually at the stage where you can run the BTC screen. What we need to do is copy this command here, which runs the main file in the BTC screen software, paste that into your terminal and run that. And then what you should see now, if you look at your Raspberry Pi, is the screen will start to flicker as it initializes that driver and all of that software that we've been installing. And then eventually you should see the BTC screen show up. Next thing we've got to do is sort out the daemon, which is going to start this when we boot our Raspberry Pi, because at the moment we're just having to run it manually. So hopefully that test worked for you and you've now got the BTC screen running on your Raspberry Pi. But what we need to do next is just set up a configuration and also set up a service so that we don't have to run it manually each time we start the Raspberry Pi up. So the first thing we're going to do is cancel the running program. So for Windows and for Mac, if you just hold Control and C, that'll stop the current running program, which was that main.py, and you'll probably see your Raspberry Pi screen start fading out now as the program stops running. You can also press enter a couple of times here just to get a fresh command prompt. And if we scroll down to the screen configuration section, there are some things in here that we can change. We're just going to change the refresh interval. It's currently 15 minutes and we're just going to bring that down to 1 minute. So what you need to type into terminal is this command here. I'll put this in the comments too, and it's just going to open a text editor within your terminal which allows you to make some changes to this file. So if we just paste this into terminal and then press enter, you'll see that it will bring up a configuration file which matches what Dr Mod's put on his GitHub page. And you can use the arrow keys here just to scroll across to the refresh interval and remove the 5 so that we bring the refresh interval down to 1 minute. To write this file out, you have to press Control and then X. And then what it will ask you is, do you want to save the modified buffer? So just press Y. And then the next thing it will say is, what file do you want to write out? So all we need to do is just press enter, and it will take you back to the terminal screen, and that configuration with a refresh interval of 1 minute will be saved. And then the last thing we need to do is set the auto start. So Dr Mod gives 2 methods of how to do this. The first is using a local RC file and the other one's using a services daemon. I've tried this step 1 and it doesn't really work for me, but I have found that the second step does work really well. So we're just going to be copying out these commands and maybe using the text editor to add in the configuration that he recommends. So the first command is this sudo nano command to create the actual service configuration file. So we're just going to copy that, paste into the terminal and press enter. And then this brings up a text editor, and what we need to do is just paste into here all of this. If you don't want to copy all of this manually by selecting it, there's a button on GitHub that you can just use to copy it in the top right hand corner. And if we paste that into our nano editor, we can just save this out. So much the same as when we were modifying the configuration file earlier, just press Control and then X, press yes, and then press enter, and that's all saved there now. So the last 2 things we need to do before we're finished is this command here to enable the actual service that we've just created. So if we copy that and paste it into the terminal, you'll see here it's going to create some symlinks. Just wait for that to finish, shouldn't be long. And then finally we just need to start that service. And you should see the BTC tracker pop up again on your Raspberry Pi. You'll probably just have to give that a couple of seconds to start. You can see now in our terminal that we've still got full access to our terminal command prompt. However, the program is now running. There's one thing that is worth doing to test if this service is going to work properly. So in here, if you type in sudo and then a shutdown -r now. And what that will do, it will send a restart command to your Raspberry Pi, so you'll see it switch off and the screen fade, and then just allow it to start back up. You should see the BTC screen start automatically. It may take a little bit longer, just be patient, maybe give it up to 5 minutes to start, but hopefully you'll see that new BTC tracker pop up on your Raspberry Pi, and from this point you're all good to go. Thanks all for watching, hope you have a great day.